personalized education at scale. So at the intersection is where you could expect us to launch products, and where we'll be presenting some products today as well. In developing these solutions, what's really key is really the time to market, what we've seen. So historically, deploying these models have been taking up to 18 months for education companies. And in fact, only 15% of companies that do big data investments bring solutions to market. We wanted to change that by providing easy-to-use APIs where you, in 2 simple API calls, could implement personalization into your learning experiences and bring solutions to market and make them production ready in a few weeks rather than months or even years. In developing these solutions, another thing we think is really, really key is to publish openly. So we've been fortunate to participate in Duolingo's open competition. And we see that initiative as really exciting because it's both about bringing open data sets to the research community that allows us to evaluate the models and approaches that we're taking to this task and benchmark them against each other. And in that competition, we were fortunate to win all of the categories on all evaluation metrics. And in addition to that, we also participated in the CogX competition and ended up being selected as the best AI product in education. But coming out of the Nordics, what's really important to us is the values that we set for ourselves and the principles that we have in developing these solutions. And one of the key principles that we've taken on is explainability. So across the solutions we're presenting here today, we see that we're taking an explainable approach to AI. That offers transparency to educators, so you can actually understand what's going on behind the scenes. But equally, that allows us to do much more effective quality assurance. If recommendations are not as we want them to be, we understand specifically why. Another aspect is privacy, and that's another area where we want to lead in research. So there's a lot of exciting progress going on there in federated learning, and we're going to discuss that in the panel today as well. How we could retain privacy at scale while still offering state-of-the-art personalization. Another aspect is collaboration. So inherently, the approach we're taking is collaboration, because we're not doing the content, we're not doing the user experiences, but we're focusing on the machine learning component. And then we partner up with the best in content, the best in user experience, the best in pedagogy to combine our expertise. So we're very open to collaboration, both with industry and academia. And then on transparency, we aim to openly publish our results, and not only sort of the good, but also the shortcomings of these technologies, which can open up for academia to do research in how we could address those. And one approach that we really subscribe to is sort of CSI whole child approach. So when we look at this approach, what we're actually looking at with the technologies that we're applying is a small part of the puzzle. But what we're seeing is that students with mentors are 54% more likely to graduate from college. So what we're looking at here is how can we combine these approaches to a much more whole child approach, where we not only look at the academic development, also the physical, the cognitive, and so on, to form a much more holistic picture of the students. And I think this is really important to understand and address, because in this area is where a lot of the shortcomings have been in applying technology to education. We're not thinking about the whole child, but very specific areas. And when we do that local optimization, the whole child suffers. So I think it's really important as we bring these solutions to market that we think about the full spectrum of needs. So the first product I wanted to share more about today is Sana Learn. So what we looked at there was the time to market aspect. So in speaking with educators, with publishers, education technology companies, what we found was that a lot of the solutions were costly to bring to market, required a lot of manual tagging and work, and they were also very rigid in their structures and not very explainable. So we asked ourselves, is there a better way to personalize? One that's easier to bring to market, more explainable, and delivers better results at scale. And in speaking with teachers, this was one of the core aspects that came up, that teachers found that the systems were very rigid. It was sort of this approach to adaptive learning where you would present the same question over and over again. And they were really requesting a more holistic way of personalizing the education. And when we look at bringing personalization to market, one thing I think is really intriguing is sort of this picture. So this is a tensile structure that has been algorithmically optimized using genetic algorithms to handle pressure more effectively. And if you look at one of the designs here made by a computer, it looks like nothing a human would have designed. It looks a bit out of this world. And I think this is interesting in that when we as humans encode our knowledge into systems, they end up being simplifications of the phenomenon. So you can think of this as a curriculum, right? That this first tensile structure is what we thought would be the optimal. But then once you pressure test it, you figured out this optimal structure that delivers better results. So I think this is kind of intriguing, an intriguing analogy of where we might be heading, finding fundamentally new ways of teaching knowledge which have been optimized by utilizing data. And if you look at the content tagging aspect, this is one graph that's completely derived from data. And if you look at each specific component of it, it really makes sense. But just using historical data, the natural language of questions, we've been able to derive this mapping. And this is potentially what you could see as that sort of tensile structure. If you add another dimension to it, here you can also see the arrows. And the size of the arrows is the exact strength between the connection of each of these concepts in the graph. So this is really what we're moving towards, curriculums that have been derived from data and which truly capture the nuances of learning, which capture those 100 billion neurons making trillions of connections. So at the very heart of Sana Learn is the proficiency model. So this proficiency model models exactly what a student knows, their knowledge gaps, what they've already mastered, and where they're ready to move forward. So this proficiency model lies at the heart of all of the recommendations we give. But we also combine that then with specific strategies for different areas. So one of those strategies is, for example, doing adaptive testing. So in real time, figuring out what is the optimal next question to give a student to maximize your understanding of their knowledge. So this allows us to do much more effective assessments, which then feeds into the subsequent strategies, but reducing the number of items by 50 to 90%. So this is one way of doing much more effective assessment that we could bring to scale. Another really important aspect is to identify the student's knowledge gaps. So what are the areas where a student might need remediation, and what resources do we have to surface to address that specific knowledge gap? So based on the proficiency model, we can know exactly what does a student know and where are they struggling, and then surface resources to most effectively help them address those specific knowledge gaps. Another aspect that we have to consider is the difficulty of the content. So what we found on average across all students is that when students have around 70% probability of getting exercises correctly, that's when they stay the most engaged. That's the proximal development. But what we're seeing is that this actually changes depending on the use case, depending on the students, depending on where they're at in the session. So optimizing this difficulty is very core to the recommendations as well. And then we need to combine that with where does the student have the most learning potential? Where do we see that the students could move forward and learn the most? So we also do a calculation of how the next recommendations are likely to impact the student's proficiency, and based on that can also understand where to move forward. But when you've mastered a concept for a lot of different applications, it's also key to retain that over time. And this is one of the most proven phenomenons, right? So it's really fascinating. It started out with Hermann Ebbinghaus doing these tests of random syllables on himself. But what we found is that, of course, there's much more nuances than Ebbinghaus could capture with a sample of one. How we forget math might be different from language learning. If you're a Swede learning English, learning camera will be very easy because camera in Swedish is kamera, so that will decay very differently from if you're learning ubiquitous, which Swedes will have to review 15 times. So modeling the decay of knowledge to most effectively retain it over time is another aspect that goes into the recommendation strategies. And all of this together can be uniquely configurable depending on your use case. So your use case might be one where you're prioritizing more the adaptive assessments, or where knowledge retention is key, or proximal difficulty is key, or where you want to focus on the remedial resources. So what we found is that by making this strategy uniquely configurable, we can easily adapt it to your specific use case. And that's truly what allows us to be content and platform agnostic, because we can tune the platform to the specific needs of your learning products and your pedagogical strategies. And across sort of the spectrum of our partners, we have anything ranging from companies working in nursing, to math learning, to language learning, corporate education, and we're working across the entire spectrum. So independent of what you're teaching, as long as it's digital, as long as you have some assessment that's tracking against learning outcomes, using these configurable strategies, we can adopt to that platform. So with simple to use APIs, you can implement personalization to offer these different strategies across addressing knowledge gaps, optimizing the difficulty, optimizing for knowledge retention, and bring that to market in weeks. And here I wanted to show you a very practical demo of that in action. So here you can see a math learning product powered by Sana. Here you can go through the chapters, and you can practice on a specific chapter level if you want, or keep your stars from fading away for knowledge retention. So they've created specific features around this. But here, as you're practicing, you're not only receiving the recommendation, but also why that recommendation was given. So this recommendation was given because you struggle with multiplication with 2 and 4. And here, as the student continues, they receive another recommendation, which is because of their knowledge retention. So we're recommending that to keep it in long-term memory. But we not only can recommend sort of these exercises and multiple choice questions, but also if a student is struggling, we can recommend a theory example, which is the theory which is expected to address that specific knowledge gap. So in real time, as a student interacts with this service, we optimize the next recommendation that they see in real time, and then present them with the theory, with the questions that are likely to improve their learning outcomes the most. And when a student is done with the session, they can see exactly how the recommendations improve their knowledge, and truly get a transparent look into how the recommendations are affecting their learning. So we've been really coming to the previous principles. We've been fortunate to run a lot of tests with academia and A/B tests in schools, as well as outside of schools in our other professional education applications and so on. And in one test we ran in Swedish schools where the students received the exact same learning experience, the students that got the personalized, Sana-powered personalization mastered 44% more problems. So that was a really exciting early testament of how these recommendations can improve mastery and really improve how much the students learn in the same period of time. Another case study we quite recently launched, I'd like to welcome Valentino, our Director of Business Development, to share, who will also walk you through one of the use cases we have. So give him a warm hands.
Thank you, Johan. It's great to be here. Yes, first I'm going to show you some incredible results we obtained using SanaLearn. So there are a lot of techniques on the ones that Johan has explained. We have applied them for remediation, and we have performed what's called a randomized control study, meaning that there were two groups of students. Every new student would be picked at random to be in the control group. The other would go to the powered by Sana group. The students who were in the control group, they would get exactly how this specific course from a partner of ours looked like earlier. Okay, so no changes. The students powered by Sana would get the chance to perform remediation using personalized review sessions powered by SanaLearn. Periodically, they could go in and do a remediation. So, what we have seen, so the results were incredible. What we expected, what you expect in this kind of control studies is an increase of 5 to 10% if your algorithms are working well. This kind of increase are unheard of to my knowledge on bringing like data science solution to market. We computed for both groups the skill of the students and the retention rate of the students. How did we compute the skill? We basically used an industry standard, which is called IRT ability, to compute the skill of students, and we have trained the IRT model to look at the interaction data of students on the standard parts of the course. So we did not take into account the personalized review sessions that we were serving to the students, but only look at the standard parts that were equal in the two groups. This is the result in terms of, we observed 80% higher skill for the powered by Sana groups that have access to the personalized review session powered by SanaLearn. And how do we compute retention? What you see here is a 3 days retention rate. So we have looked at the rate of students that would come back within 3 days.